All right, ladies and gentlemen, here we are at Confluence Conference Current 24. I'm with Sean Clowes. He's the Chief Product Officer, and I've been tracking Confluent for about a decade now, and you guys have made some tremendous progress. And Sean, I wanted to start off just saying, when I learned about Confluent the first time around back in 2014, interviewing Jay Krebs, I thought to myself, this is fascinating. This is a way to supercharge your use of data throughout an organization and to really solve for a lot of the hurdles and challenges and problems that we've had to tackle over all these decades with traditional data management practices. And this is a whole new way. Now it needs infrastructure, it needs an ecosystem, it needs mindset change and all these things. And it feels like we're on a pretty powerful path right now to achieve that. Where do you feel we are right now in terms of streaming data platforms really coming into their own and being the de facto standard for the most mission critical applications in business?
Yeah, I mean, I think we're really at that moment. Confluent began about 10 years ago when our founders began with Kafka, and Kafka was basically a whole new type of data infrastructure that focused on the way data moves rather than how it is stored. And that's basically a streams. And the idea is that you can push data from an application and then have other applications access that data without needing to know about the other application,
Right.
and to be able to do it on their own time. They don't have to be there. They don't have to receive the data in milliseconds, but they can if they want to, or they can receive it hourly or minutely or whenever they need it. So applications can collaborate on real data, but not need to know about each other. So the data becomes separate from its applications.
Right.
That turns out to be like a super compelling capability. It ends up replacing a bunch of other technologies that just didn't really do the job very well, Yeah. And so what we've seen over that 10 years is like Kafka has become ubiquitous. It's like effectively everyone knows what it is. It's present in over 150,000 different organizations all over the world. Like it's really reached like massive scale. And that's because of these compelling capabilities. It's just a better way to build data flows. Now, as you said, that's kind of audacious though, because you're saying, hey, let's replace these things that we've been using in database management for a very long time.
Right.
But honestly, like many of those things never felt good. They were just the only way, like the only way is to move files around in batch. The only way to manipulate data is to do it in databases. The only way to connect to things is through, elaborate connectors or custom code. If you say, well, no, like let's spend 10 years and build this streaming capability, then build like a connector foundation so that you can connect to all of the data, and then build a governance foundation so that you can know what is in the stream and what it means and convert it into a data product, like a noun, rather than just a bunch of bytes. Like you can reason about what it is. And then if you can process that data while it's flowing, like instead of putting it in the database, literally do all the transformations and manipulation you would do in real time, what you get out the other side is kind of like these foundational data products that can be put to use for any goal. Like you can build an online application, you can build notifications, you can do fraud monitoring, you can put in your data warehouse or data lake to, do analytics if you want to. One source, one unified source of data, and one foundational way to move it. It's kind of compelling, audacious, but compelling is maybe.
Well, it is, and you used a magic word there in the early part of that bit, governance. I'm old enough to remember when governance was just something on the shelf that you would hope someone cared about, and you could govern at the database layer or you could govern at the application. Both were difficult. Both were certainly very difficult at scale. But if you don't govern just about everything, you don't really govern anything, right? That's the problem with governance. And so where will you find some substrate, some choke point? And you don't want it to be a choke point, right? You want governance to be guardrails. And it seems to me you've put some good thought into thinking about how you can achieve that in the streaming world. So it's governed after it while it goes across the transom. So you don't get something that wasn't ungoverned, is the whole idea, right?
Yeah, we like to think about that idea as shifting governance and processing left,
Right.
right? The only form of data that really matters is the form it is produced in the moment it's born. Like all data is born. There's some, usually a system somewhere producing the data, usually in reaction to something happening in the real world. And then it produces that data and it pushes that data out into the world. Now, traditionally, that would just happen as a bunch of records in some file somewhere, or maybe some, record stored in a database somewhere. But the team that produced it was not responsible for it. Like they didn't view it as fundamentally their thing, like their thing that they were giving to the world. And what happened, obviously many years ago was in engineering, we moved to this idea of API contracts. Like I provide a service to you. Like when you call my thing that does a certain thing, I promise you it will work. It will follow the following characteristics and it will just work. What we're seeing in data is the exact same thing. The idea that a data is a form of a contract. So when I push data into a stream, I want to have a contract. I want to tell you what the contract of that data is. And I'm saying to you, I'm giving you, let's say it's a payment stream. I'm giving you a payment stream. The payment stream will have the following fields and they will have the following meaning. I'm promising you that. Like that means that you can then rely on it. And so this shift left governance that we're talking about means that from the moment the data is born, I am providing that contract. I'm enforcing that contract on myself and giving it to
Interesting.
you that then enables you to take advantage of it safely. So you've got these safe foundational data assets you can use to build things.
Yeah, that's very interesting. And it does speak to the value of solving problems upstream. The further upstream or shifting left in that particular parlance, the more accurate it will be downstream, right? You always want to solve problems as far upstream as possible. And so if you can solve it at the moment of inception, at the moment it goes into the transom, then it's not a problem anymore for everyone downstream from you. And that's the plan. Now, the difficulty again is getting to a place where you are important enough to have that power, to have that capability. And I feel like Kafka is there today.
Yeah, I mean, the advantage of Kafka is there like in most, companies all over the world when the data is first born, because it has become the de facto way in which applications publish their data. They push their data. Why is that? Well, as an engineer, if I'm putting a data feed in a piece of code that I'm writing, what I really want to do is give the data to the world and forget about it. Like I'm
Right,
trying to do that as quickly as possible because
right,
I've got a business process that I'm running at the same time.
right.
Kafka is great at that. So that's why they've embedded that. But as an engineer as well, I do also recognize that this data that I'm producing is my responsibility.
Mhm.
But for a long time, it's been hard to conceptualize that, to express it really in terms of like, I'm promising you this, like, and to enforce that. That's what we mean by this, like our shift left governance suite. It means that I can say, as a developer, I can say, hey, I'm going to publish this message. It will have the following fields in it. And I will promise you that those will be of the following format. And then I can actually use that. I can implement data quality rules, which mean that literally in my application, when I publish those messages, if the messages do not fit that format, they're not of that structure, they won't be produced at all. So the data is clean. And when I'm debugging my code, it will actually literally give me a trace back so I can see what's happening. Why am I not
Wow.
producing the right data? All the way left. And actually, like, if you embrace this idea, it almost doesn't make sense that governance could happen anywhere else. Like
Mhm.
how can you clean up? Like if the data is wrong, if the developer creating it or the system creating it is producing wrong data, it's very hard to take false, incorrect data and make it good,
Mhm.
And once you go down this road, you end up with these incredibly complicated ETL pipelines
Right.
where you're trying to recover from some, thing that happened upstream. It's a castle built on sand. It's really, really difficult to do that. Really difficult to do that.
That's
Yeah.
very interesting. That's a very, very good point too. And when I've thought about Kafka topics as again a different architecture for managing the movement of data, I've always thought that was a very clever structure because maybe 10 people want to subscribe to this topic, maybe 1,000 people, maybe 5 people. It doesn't matter. I'm going to publish it once and you can subscribe to it as you need. So it really kind of inverted the whole architecture of data storage, movement, access, delivery. And that's why it is so disruptive. But now that you have it in 150,000 companies around the world, I mean, you clearly have seeded the market. So we're now at a point where I think enough people understand this sea change and you're starting to get somewhere. What do you think?
Yeah, I mean, I totally agree. That's why we've been spending this time building out this platform. And we talked about the streaming bit, the Kafka bit, which is like foundational and everywhere. There's this whole connector suite, which enable you to stream into and out of all these applications, whether or not they stream native or not. Then there's this governance piece. The bit that really kind of brings the whole thing home is the stream processing bit. One of the problems or the opportunities is that streams as they're produced are often like very useful. Like if you have a contract applied to them, they're very useful. But often you want them slightly enriched. Like you might want them joined with another stream, or you might want them summarized in some way, or rolled up, or hourly windows. Like you end up wanting these kind of they are using that data, but you want them slightly evolved or improved. And in many cases, like the story was so great, except when you reach that point, you're like, well, I guess I'm going to still put it in a database somewhere and process it.
Right.
But what we've seen, over the
Funny.
past 10 years is we've actually seen like a huge amount of like academic and now commercial implementations of stream processing at scale. And the I guess the most popular example of that is Flink. Now, Flink came out of academia in Germany, actually, where they had literally set out to think about it as like turning a database upside down. They said, hey, if we want to operate on data, we want to manipulate data the way we would in a database, but not have a storage layer. It is not stored, it's just in its streams. How would we do that? How would you build a system from the ground up to do that? And so Flink, you can think of Flink as like a disembodied database. It can run the same sophisticated queries and processing you would imagine doing in a database, but on the data in real time as it flows in milliseconds. And what you get when you do that is you kind of get these powerful streams, well governed, connected to everything, and you get rich streams that might represent very complicated business objects. And they're still real time. They're still reliable. They're still real time. So I can do stuff like I can have like a customer 360 record that's being updated in milliseconds, and I can update. And when something happens to your customer record, I can send you a notification. I can, do whatever follow-on action I need. I can take advantage of all of my enterprise's data, but like kind of in this real time way. Or if I don't want it in real time, I can still access it, from my data lake. But it's kind of just one approach to solving my data at the root, like solving my data problems really at a fundamental level.
Yeah, that's very interesting. It's a good way to put it too, because there are so many problems you can solve in the now. And I always look to the cliches. There's no time like the present,
Yep.
right? Or well begun is half done. A stitch in time saves nine. There are multiple expressions around that very reality, which is the sooner you act, the sooner you're going to solve the problem. Fraud detection, for example, is a wonderful use case because the actors change. It doesn't have to be the same IP address, the same process, the same person, whatever. All that stuff changes all the time, but the patterns are very similar.
Yeah.
So being able to, in real time, tackle some of those challenges, that's a huge use case. How much of your business would you say is in fraud detection?
Oh, yeah. I mean, absolutely. We have a lot of customers applying this type of technology to fraud detection, but it's that and so much more because, that example you just gave, sure, but what about like real-time inventory management or personalized shopping experiences or like highly intimate online banking experiences, personalized? I mean, like once you start down this road of going, okay, if I could have all of my data, all of my nouns, I like to think about it as nouns of my business. If I'm in banking, it's going to be payments and customers and debits and credits and ATMs and stuff like that. If I'm in logistics, it's going to be deliveries and drivers and locations and dispatch centers. Like those are my nouns. If I have those nouns and they are just there and they're all in real time, what could I build? And the answer is like everything. Because fundamentally, what does a project typically look like in an enterprise? Somebody somewhere goes, oh, it'd be really great if we could have the following customer experience or employee experience. Then everybody goes, okay, now what do we do?
Right.
We have to figure out where the data is. Like, so basically a whole splunking exercise happens where we go and try and figure out which systems master that data. Then we write a bunch of code to try and suck the data out and try and put it somewhere. Then we stand up a new database. Like we do all of this. It feels like Sisyphus dragging a rock up a hill because ultimately we're just like constantly repeating the same work over and over again to get the data we need to power our use case. But when the data is like separate from the systems that created it, when it's literally a thing you can reason about and rely on and build on top of, it kind of unlocks everything. And you start to get into this world of like, it is easier. The world is dramatically easier when your data is available and real time. Like you can build anything that can be built.
Right.
Yeah.
Now that's very interesting. And I think that's why there's a lot of excitement in this space, because again, you've sort of jettisoned all the old unpleasantness of persisting data, getting performance from the database, fine-tuning the database to get the performance, all this stuff that we've taken for granted that we had to do because you had to increase performance. You've kind of set all that to the side. I mean, I'll give, since you mentioned Germany, I'll give you a great quote from one of my favorite philosophers, Ludwig Wittgenstein. Years ago, he wrote this whole book, Tractatus Logico-Philosophicus. And in the end, he gave this analogy. He basically said, look, and what's interesting is it's almost like he was talking about vector databases, because he wrote this book about how to mathematically define what can be said. That was his whole mission, right? Which is like, well, gee, that's kind of what these vector databases are doing, right? They're taking text, converting to vectors, converting back to text. That's why it's probabilistic. But he had this great line where he said, Now take everything I've told you and view it as a ladder and climb up to that ladder. And once you get in the clouds, kick the ladder away. And that's when you'll be in the divine state, essentially. And that's kind of what we're talking about here, right? Where it's just moving. It's like clouds moving around. All the data's in the streams up there. You just subscribe to it when you want to. I mean, it's kind of abstract, but do you see the point I'm making?
Yeah, I mean, exactly right. Like, you really need to get away from, honestly, we spend so many of our calories and time thinking about infrastructure. We're like, well, it's going to be disks and storage and networking and everything else. But at the end of the day, what it is these information objects. It's actually this knowledge that you're trying to work with and you're trying to put to work.
Right.
And I think honestly, that's always been our mission. And actually, personally, so I've been in this industry for a long time, as no doubt you have too. Like, as an engineer originally, then in sales, now in product management and everything else. Like, I think that it is kind of the information technology problem
Right.
to figure out how to put your data to work. Like, it has so much
Right.
potential.
Right.
Many organizations, people talk about data as the new oil. I think like that's kind of naive, because for many organizations, they're more like drowning in their data than they are swimming in it. They're not in a beautiful boat sitting on top of their data. They are drowning in it. They have it, it's everywhere, but they don't know what it means. They don't know how to use it. They don't know if it's safe to use. They don't know when it was created. They don't know who owns it. Like, they're kind of in this disembodied state where they can't see the wood for the trees. They can't climb the ladder, as you were talking about, to the meaning of their data and how to use it. And they're just stuck at these like kind of lower level layers of infrastructure and compute and everything else. And I guess our objective is to try and give people the freedom to not do that, to reason about their data and to figure out how to put it to work, rather than kind of just all this infrastructure and bits and bytes.
That's very interesting. Just got 1 minute left in the segment here. Really, you are enabling people to use data as it flows, which is a very different thing from a data lake where it goes and sits somewhere.
Yes.
Not that you can't touch data lakes, but I love that so what you're doing is creating all sorts of neat faucets and other ways to pull the data out as you need, with filters and hot water, cold water, all that kind of stuff, which is, again, a fundamentally different way of doing things, but a much more, wait for it, fluid way of doing things. What do you think?
I absolutely love that. One thing I would add about that is, like, when you think about the world in this kind of flowing sense, and Kafka would say in a log sense, like it's a log that you can track and you can see what's happening over time. If you want to put your computer science hat on for a second, a log and a table are exactly the same thing. So you're talking about a data lake as being at the end of a thing.
Right.
But a log and a table are the same thing, literally, from a computational perspective. A table is a projection on top of a log. And so what that means is that same stream, that exact same thing, that log that is producing this online data that you can take advantage of, can also produce a table. And with our, offering recently, which is called Tableflow, it does exactly that. So you have a Kafka topic, you click the button, and it magically just appears as a table in your data lake, the same data. You can query it in your data lake. You can use it online.
That's
you name it,
awesome.
your data, wherever you need it, however you need it.
That's awesome. Great stuff. We're here at Current 24. Another interview coming up. All right, folks, back here on DM Radio at the Current 24 conference in Austin, Texas. It's hot outside. Big surprise there. And I'm sitting now with Shashi Moolay, who's going to cool things off for us a bit as he explains what his clients are asking for in the world of Gen AI and the nexus of streaming. So Shashi, welcome to the show, and thanks so much for your time. Gen AI has captured the imagination of boardrooms everywhere. Every company is looking at it. There are concerns, but there are tremendous advantages to be had if you do it right. What are your clients asking you?
Yeah, before I talk about my clients, I think you should need to know what EY as a firm is doing, as an organization is doing in this particular regard. We actually have a 3D principle, like transforming ourselves, transforming our clients, and transforming the world. Because EY's logo is create a better working world, right? And we as firm has done investments around these technologies in billions, right? I don't have the exact numbers, but if I can send them over to you if you want.
Sure.
Right. But from my perspective, my role in this particular space, I work for a practice known as digital engineering.
Okay.
And in that, I am leading, I wear multiple different hats during the day, but I'm also leading the Gen AI piece as part of the steering committee across Americas that sits, who builds on what we are trying to do for our clients. From a client standpoint, my focus primarily has been on the financial services people, right? So most of my clients are from financial services. And if you go back 20, 30, 40 years, the systems that were built mostly in mainframes and whatnot, right? They kind of sort of, they don't have the skill sets anymore to help with the COBOL programming. And
Right.
so I think the biggest use case we are seeing in the market is from a point of view of core modernization, right? How do you want to address core modernization? Now, this is a journey that most of the banks want to go through, but they are asking for our help and our visions, our patterns, what we think is going to be helping out in the industry and help them modernize and transform. Yeah. That said, there's one other thing that from a data streaming capability perspective, some of the clients have actually started creating patterns that I have worked with them on, right? They are actually thinking about events, and not only events, metadata-based events, right? Which basically kind of sort of creates from an analytics standpoint, if you want to do forecasting models and whatnot, the key thing for that is the data quality that you have, right? Now, that is a shift left mindset. And I don't call it a buzzword, it's a mindset. It has to be applied across the organization, saying how clean, how clear your data is. The most important question over there is whether it's fit for your purpose. Data means different things to different people, right? And when you start creating analytics on it, the metadata that gets generated is even more powerful, according to me. That's where I think data streaming completely falls into place. I think about, if I have to give you an analogy, right? I think about data stream as a river. You have producers to the river as tributaries,
Right.
and then you have consumers that people take. And then you have quality gates as dams and whatnot that you build on top of it, just to make people understand the parallel answer.
Yeah,
right?
yeah.
So from my perspective, there are many other use cases, but I want to divvy it up into two different things. And especially from a data streaming perspective, I think one of the overlooked things from my perspective is the risk aspect of it. And the risk over at EY, we have kind of sort of tried to classify and categorize these risks into various different categories, right? As in data risk, technology risk, cyber risk, security risk, reputational risk,
Operational risk.
operational risk.
One of my favorites. yeah.
Exactly, right? So these are buckets, as we call them, right? And I think that is resonating with the clients a lot, right? Saying, because each of these subjects or buckets, as we call them, are actually a 2-hour session in themselves when you basically go deeper dive. The thing is, the shift left mindset from when you're thinking about data streams in general, if you shift left, you have to prepare for these things, right? But it's funny you asked me the question. One of the use cases that came when I was talking to one of the clients, he's like, Shashi, I want to measure developer happiness, right? And not developer productivity.
That's thoughtful.
Yeah, that is pretty thoughtful. I think it was very interesting too, but also has a abstract factor to it, right? How do you measure it? Right? So my question to them was, do you have anything in place right now to measure that? Right? Because one of the thing that you mentioned, that Gen AI has been a major disruptor in the industry as such, absolutely agree with that. But people are asking the question, how is my efficiency going to improve? How is my productivity going to improve? How people are going to contribute better to the organization? The question they should be asking is, do I have a metrics to compare against? When the before and after happens,
Sure.
right? You need to have a before that you can compare the after against.
Right.
Right. I think that mindset is still developing. That's the reason the AI adoption is at an infancy stage right now in the industry.
Interesting.
Does that make sense to you?
No, it makes complete sense. And, I've known Confluent since they started. I interviewed Jay Krebs 10 years ago, in fact, and I got very excited about this whole approach because, as you suggested, is flowing water. And the fact that they're saying shift left right now for data governance, I think is very encouraging, because if you make sure that only the right data in the right form gets into that stream in the first place, you solve countless downstream processes, error propagation.
Yep.
is a huge issue in any industry, especially financial services. So if you get some small error way upstream here, it's going to infect everything else like a poison in the water.
Exactly. And I think you're saying it much better way because you do this a lot. And I'm an engineer, right? I'm a technologist. I try to solve complex problems.
Right.
That's what I try. But from my perspective, you are nailing it, saying, hey, a small error on the left side is going to create lot many analytical errors down the road,
Right.
which will impact your accuracies, which
Right.
will impact your business functions and whatnot. So be very careful about how you talk about it.
Yeah.
Right? So in our world, as I said, the core mod thing, right? When we talk about COBOL code, clients have millions and millions of
Right.
lines of COBOL code that nobody understands.
Right.
We are actually trying to help them out with our journey, saying, look at this, look at that, right? Like, I don't know if you know this or not, EY has an initiative by the name of EY.ai, which is becoming very, very powerful and popular in the industry. Along that particular thing, we have our confidence index model, we have maturity models that we are actually pushing out in the market.
Yeah.
And trying to work with our client to provide that information to them,
Yeah.
saying, hey, there are multiple lenses to look at things.
Mm-hmm.
Why don't you wear this one?
Right.
Yeah. You might see blue for a little while, but it'll start making sense, right? Like, I don't know if you're a golfer or not, but in golf, there are specially made lenses that you can read greens better.
Yeah. Right.
Believe it or not.
Sure.
Right?
Sure.
So
Sure.
that is the same lens you have to wear,
Right.
right? When you're looking at your data. The biggest challenge I see is whether all the various different systems or the people who are responsible for the systems, like operations ops people or data people or security people or anybody, right? Like third-party integrations people, right? Are they aligned on the same message?
Mm-hmm.
What they want to use GenAI for?
Mm-hmm.
What's the purpose behind it?
Right.
What are they trying to solve?
Right.
Is it a new product offering? Is it a new forecasting model? Is it to get our internal people better?
Mm-hmm.
Is it to have more interactions with the partners and invite more partners to
Right.
join your business?
Right.
Right. There are n number of use cases, right? But it's not a one size fits all kind of a problem.
Right.
Right.
Well, and you bring up a really interesting point about COBOL, because as you suggest, many of these COBOL engineers are retiring or have already retired. But one of my first epiphanies working with these large language models was, hey, if they can write in German and French and Italian and English, I'll bet they can write in Java and COBOL and C++ and C#. And short answer is yes, they can. And I think we're going to get better and better at also being able to decode what all that code means and get meaning from some of that, understanding that, as I'm sure you know, Gen AI is probabilistic in nature and really always will be according to the engines that have been built. That you can get your anchors of truth and embeddings and RAG models, and these things do great work. But nonetheless, you do have to be careful. But goodness, the power of being able to quickly throw a whole bunch of code in the system and say, what does this do? Is incredible.
It is very powerful, right? Especially like, I know I sometimes call myself as the last of the Mohicans, right? Because I actually coded in COBOL,
Nice.
right? Back in the day. I'm going to like 1989, 1990,
Wow.
right? But it's a dying art as of now, dying skill, whatever
Yeah.
you want to call it. It's not available.
Right.
But I think the key word that you mentioned for me, which is very powerful, is probabilistic.
Mhm.
It is not deterministic.
Right.
Right. Till the time our AI tools are trained to that a level that
Mm.
they practically become deterministic, that each time you send them the same code, they will generate the same
Right.
documentation for you.
Right. Right.
That's what the difference is. And people need to realize that.
Right.
Like, these AI models are hungry for data. And the only way to supply data to them is data streaming.
That's interesting.
Yeah.
I'm going to throw a fun quote from a developer at you, just because I think you might appreciate this. And it does speak to the power of human creativity. And he once said, busy is the enemy of creative. What do you think about that? In other words, if you're too busy, you're behind the 8 ball and you're just chasing your tail, basically. You got to take a few seconds to think about things, to find the new answers. And I think that's always, not always, but for a long time, that's going to be the domain of human beings, because we are very creative creatures. And so, and like yourself, you can look at incredibly complex scenarios and think, wait a second, we can solve this by shifting left and getting better governance in the data that comes downstream at first. And that'll solve all these other problems. Because otherwise, if you're solving problem X, Y, Z, PDQ, all over here, if you had just solved upstream A or B, this could cause tremendous benefit throughout the organization. What do you think?
I agree. Means to a certain extent with that particular quote, I will actually, the only difference I have personally for me
Yeah.
is some people are very good with compartmentalizing their minds,
Right.
right? They can contextualize and change context on like that,
Yeah.
right? For those people, busy is really good, right? You don't want empty compartments, then nothing happens, right? But from my standpoint, I do agree to that particular statement, but I am working with EY and the people I have around me, my leadership, the people who work for me as teams and whatnot. Yeah, gems of people, just makes my job easier, right?
That's nice.
Yeah.
That's very nice. So Gen AI, we've got a couple minutes left here. So many different applications. Some of the advice that the folks from Confluent were giving is to focus first internally and use it to help your teams better understand processes, documentation. And one of the things I find so compelling is being able to take some huge policy document, feed it into an LLM, and just ask it all sorts of questions about how to do stuff.
Yeah.
As opposed to reading the whole thing or going back to the index and seeing where did they talk about a policy for hiring. That is very compelling stuff, right? That's a great way to improve your productivity easily. What do you think?
Yeah, I think organizations in general, when I'm talking to my clients, we are basically asking them, where do you stand in this journey? Do you have a talent program, a skill program? Are you skilling your workforce, making them understand the toolings available in the market? They are changing at an exponential rate,
Wow.
right? Like LLMs are changing, if I use a model today, by the
Right.
end of the day, I'll have a new version of it.
Right.
Right? So when things are exponential rate, how do you react to it? And don't always jump on the thing saying, okay, I'm going to use this. That's not how you should think about it,
Right.
right? It's more about creating a path for your journey,
Mm.
following that path with complete due diligence and focus so that everybody is aligned along the way,
Yeah.
right? The data, if we are talking about purely data journey, data governance that you brought up, or AI governance, I'll even go like 20 feet high about that.
Sure.
It's a bigger thing. You
Right.
have to plan for it in advance.
Right.
You cannot solve for it later,
Right.
right? When the data is already messed up. You know?
That's no, you make an excellent point, I think, to close on here, which is that, as you know, what gets measured gets managed. And
Correct.
if you don't have metrics, you're not going to be able to figure out the value later on. So
Correct.
taking those first steps carefully, really, really important. 30 seconds.
I think do your diligence, understand your use cases, what you want to achieve through this journey. That should be your starting point if you're starting with the journey. If you're already in the journey, retrace your steps and figure out what needs to be controlled better.
Interesting. That's good stuff. Wow. Shashi Muley, Ernst & Young, thank you so much for your time. Very, very good advice.
Thank you for your time. Really appreciate it, Eric.
You folks will be right back, folks. You're listening to DM Radio. All right, folks, back here on DM Radio. Next up, we have Serena Cho from Elastic, and she knows a thing or two about search. And we were just musing moments ago about the evolution of search and what a great job Elastic did at solving for some of the complexities that gave even Google a hard time years ago. But Serena, tell me a bit about what you're working on with our friends here at Confluent.
Well, thanks for having me. And I'm really excited because Confluent has been talking a lot about shifting left, bringing good data governance in, great data streaming capabilities into like how you treat data. And that's very in line with our stance at Elastic. We know that we want to provide that kind of security and governance at every layer, from retrieval to the storage of your data as well. And we have several use cases and customers who trust us today with that data. So on that, this is why we consider Confluent a great partner on this.
That's very interesting because streaming data is a much different paradigm than the old-fashioned way of persisting data and then doing something with it, right? In streaming, you're capturing the value as it's floating across the transom, basically. Tell me how the Elastic environment intersects with data streaming? What are some of those use cases?
Well, the great part of Elastic is that we're a critical part of architecture for many GenAI applications, and chat. And really, what we care about is having great data to be able to feed as context to large language models, to use that for servicing various use cases. And honestly, the fact that your data is being streamed is an interesting way for you to get your data into the Elastic ecosystem. But that's just one of many ways that you can get that because we are an API first platform. So you could be getting your data into Elastic through API clients, language client, pardon me. You could also be using several managed ingestion mechanisms that we also provide. We're probably most famous for Logstash, which is a pretty popular option. But honestly, our focus is being able to partner where the developers are with the tools that they prefer to get their data from all sources.
That's very interesting. So in my mind here, I'm connecting the dots about what Elastic brings to the table. And you bring up an excellent point on governance and of course, security, but only allowing the large language models to work with data that is proven, that is trusted. That's going to greatly increase the accuracy of your GenAI output. Because as we just spoke moments ago with our friend Shashi from Ernst & Young, trust is extremely important.
Yes.
And these LLMs are probabilistic in nature. They are not deterministic. And so the more you can feed them highly trusted, governed, secured data, the better the results you're going to get. And let's face it, once trust is broken, it's very difficult to rebuild.
Yes.
So it's important for organizations to keep these things in mind. And Elastic has an architecture in place to be able to bring that power of context, of search, of discovery to this wild and woolly world of large language models. What do you think?
Oh, absolutely. And it's complex because you really need not just a retrieval engine with all of the capabilities that we provide in Elasticsearch, but you need a platform of tools so you can be able to change the relevance of how you retrieve it. Perhaps you might be using vector search. You could also be using just a plain BM25 search and using that as context. And we actually have several customers who do that today. They have an existing search experience. They're able to take that, use tools that are maybe more traditional in approach for how they tune the relevance of that. And they might be on a journey to add in vector search for a combination that we call hybrid search. And when they do that, they have a whole new level of kind of tuning mechanisms that are available to them. They can incorporate fine-tuned models. They can also be using out-of-the-box models that we provide because we do have some models that we provide out of the box. And all of that adds up to great components that lead to that better result and that better context for the right end result from a large language model. On top of that, we also have a capability that we kind of talk to as solutions. We already come out of the box with an observability and security solution. So it's all rolled together. You have out of the box great tuning mechanisms for the challenges that you just described wonderfully. And you also have governance with our security solution and observability when you're ready to go to production with all the above. So you have an all-in-one ecosystem for those challenges.
Yeah, that's very interesting. And I think you're speaking to the complexity of the landscape and the importance of having a platform, having the tooling, having the bells and whistles, if you will, the knobs that you can adjust to get the frequency just right. You think in old world fashion of a radio station, you want to get right on that proper frequency to get the signal. If you're off that frequency a little bit, it's going to be staticky.
Yeah.
And what you want to do is get the capacity to fine tune the frequency of your organization with your organization's data and thus leverage GenAI responsibly and in a governed fashion, right?
100%. I couldn't have said it better myself.
Yeah, that's very cool. Tell me about vector search too, because of course, all these vendors are now adding vector search.
Yeah.
And there are different layers. I mean, actually feeding your embeddings into a model. I think about, well, how do you do that? And I'll just tell you the aha moment that I had with these models is recognizing that when you're training a model or fine tuning a model on a set of text, it's not just capturing the text like you think in the old world way of strings being put into cells inside of a spreadsheet somewhere. You're adjusting the weights and biases of the parameters. And that's when I thought to myself, well, that's very interesting. That's why it's probabilistic, but it's also why it has such tremendous capacity to articulate things in different ways. And I realized, well, if you had enough parameters in the right architecture, these things can speak better than humans in more organized fashion. They don't forget things, if you will. So there are lots of benefits to going that route. How does Elastic fit into that? What sort of vector search capabilities did you build or buy, or tell me a bit about that?
That's a great question. I think the key choice that I would focus on is that we give a blend of out-of-the-box capabilities that are supported and guaranteed a level of support and indemnification from Elastic itself.
Interesting.
But we also are part of the ecosystem. I described to you how we want to meet the developer where they are. And that means that we need to have support for their choices, whether they're taking a model off the shelf, maybe they're fine tuning that because they have the expertise to do that in-house, or they're personalizing that for their use case. Because at the end of the day, you want something that is unique to your line of business, to your customers' concerns.
Interesting.
And we need a platform that enables that choice. And so your question was, did we buy something
Right.
or did we build something? We did all of the above.
Okay.
Mostly we built something. We trained a model. This is our proprietary
Oh.
sparse vector model.
All right.
We offered that. It's already in GA. That is a great default for people to lean on.
Yeah.
And we had planned more as well. This is something that you can't just offer a model and be done.
Right.
To keep it fresh, you have
Right.
to retrain it. This is the endeavor that all vendors are having to do. But when you're talking about that choice point, being able to enable a developer who is generating those embeddings outside on the infrastructure of their choice, they should be able to still pair with us and utilize that to unlock new use cases above and beyond what we provide.
Yeah, you mentioned sparse vector search. This is very interesting stuff. What I've learned working with these things and studying is that for subject areas that are widely published, they're going to be very, very good. It's when you get into fringe areas that they start to hallucinate, is the term that's used, because there's just not enough training there. And so they give an answer, they generate an answer, but it's not grounded in facts because they don't have enough facts yet to feed into that. And when you say sparse vector, I think that's encouraging because what it tells me is that you thought about that and said, on the edges, it's going to be a bit dicey. So what can we do to control that while still having a robust center of gravity, if you will? Is that about right? Or can you talk about that a bit, what that means?
Well, I should clarify because most people are thinking about vector embeddings and they're usually thinking about dense vectors that are generated by particular models.
Okay.
They have a performance characteristic that requires maybe more memory or RAM. But for a sparse vector model, this is one that generates tokens. There's a couple of different performance characteristics for it in that if you're using a technology like we are, like Apache Lucene, you have an inverted index. A sparse vector model generates tokens that are a little bit more explainable. They also fit into an inverted index really well. And so you can get some great relevance at great speed. So it helps with scalability. And it's just a different dimension in how you might want to architect your environment. It's a great option to add on top of the flexibility that we provide with dense vector models in the platform.
Wow, that is very interesting stuff. So dense vectors, sparse vectors, this is interesting stuff. We got one more podcast bonus segment coming up, folks. So send me an email if you want to be on the show, info@dmradio.biz. That comes right to me. We'll be right back. You're listening to DM Radio. All right, folks, back here on DM Radio, time for the podcast bonus segment. We're learning about Elastic's model, and I'm dying to know what went into this. So you built your own model, you trained your own model, and you mentioned that the tokens are more explainable. And explainability is a huge, huge issue in the world of AI, and it's going to become more and more important over time. But you know what? Humans aren't very explainable either. Right? When we act, it's like, do you even know why you did something? Some people do if they're very self-aware. But tell me a bit about how you were able to architect tokens that are more explainable. What went into that to be able to produce this?
Well, so for those of y'all who aren't looking at the data to look at a dense vector embedding, it's really just a series of numbers. And you can't really intuit what this number really means. You perhaps can see that it's quantized or stored in float. There's not much that you can say other than cool, my vector embedding is there. And you might be using tools to visualize like the closeness in dimensionality or in vector space, which some vendors do offer. But when I talk about explainability, the reason why sparse vectors are interesting is that when you look at the generated token, there are sometimes people who kind of almost mix them up with synonyms. This is not the case. They're not actually synonyms. They are tokens. They could be a particular fragment of a word, or it could be partitioned and such. But because they can see it and they can see kind of generally how it's laid out in a more explainable way, that feels a little bit more intuitive. Now, that is a little bit harder to kind of say that it is the right level of visibility. And in fact, there's a lot of discourse that we have to say, we know that customers love that they see these tokens, they feel more explainable than dense vector tokens. But it's more important that we get people to think about their relevance. People are searching really for more control in this space. And so that's why they gravitate to something like, oh, look at these explainable tokens. But what we've learned from this is that this is really just a symptom that customers who are coming from a previous perspective of Elastic, they're thinking about BN25 and they're saying, wow, it used to be so easy. I could boost the relevance of a title, or I could potentially pin a result with this particular description that had a lot of control to it. And so when we see this from our customers, what we are able to tell them is, here is your world with Elastic on how you can get some great transparent insight into the explainability of each component, whether that's the model itself, how it's laid out in your data, how it's being transformed by your data. Being able to say that that's transparent at every level of the architecture is really the answer to that question, why people are so interested when they think that a sparse vector is more explainable.
That's very interesting, and it makes a lot of sense because explainability, as we know, is very important for AI. Certainly in regulated industries, you're going to have to explain how things got a certain way. And just to explain to the audience, these vectors, they are literally, it's a point, an array for a certain direction in a particular direction for a certain length, basically. And so dog, every time dog gets vectorized, it's going to be in the same area, basically, but it can be in, depending on the context, it can be slightly different. So to your point, they're not necessarily synonyms, right? They may look the same, but there are little bits of contextual data that make it very different. And that's what improves the relevancy when you search over time, right? Whether you're fine tuning or using a RAG model or whatever your approach is. And that's what is allowing you to get closer and closer to the nut. Is that about right?
Well, yes. And, you know, the interesting part of the relevancy tuning is that in part of what you're saying as well is that you also want to combine this in a deeper way with analytics. And the types of analytics that you want to increase your explainability of the session, like you said, you want to be able to see the full governance picture. We talked a little bit earlier about that shift left. Not only do you need that transparency across, but the types of analytics that you might expect in the system also has to change in some ways. It's not sufficient anymore just to get your traditional click metrics. Like I clicked on the third position on the search results page. That's still a meaningful signal, but there's also signals that have to be emitted based off of the characteristics of the model you've chosen itself, whether that's a sparse vector model, you might be looking at the generated tokens. If it's a dense vector model, you're going to want to look at your strategy for quantizing that and saying, did that change my relevance? All of these things end up having a different set of challenges that you need a new class of analytics for.
That's very interesting. And I do wonder to myself how many analytics use cases will be solved by vector search. Because let's face it, querying a data warehouse is not inexpensive. It does cost money to do that.
Absolutely.
And some of these models can handle many of the requests without going to that added expense. So it's just fun to recognize that the data warehouse, I don't think is ever going to go away.
Yeah.
It's a component part. It's a deterministic system. It's very important, but there are all these other ways to examine problems and to do discovery and to do understanding. And that's really the whole point of search, right? Trying to find something, figure out where it fits, and then explain it. And I think it's very exciting that Elastic is moving in this direction to leverage its capacity to deliver that kind of analytical capability. What do you think?
Oh, absolutely. And that's actually why, if you've seen some of the recent rebranding, we were no longer just a, scale, speed, performance company. We're a search AI platform.
Interesting.
And we do search analytics and also provide great search alongside our vector database.
Well, and the reality is these natural language interfaces will absolutely pull the attention of executives. I don't think there's any going back to that model. And so the more work you can do on the infrastructure side, on the shift left plan, the better off you're going to be in the long term. And you got to do that blocking and tackling now or very soon. What do you think?
Oh yeah, absolutely. If you don't do those things, if you don't like incorporate that type of kind of visibility and compliance at every level, you'll be caught flat-footed, and that's not where we want to be. We don't want to strand customers in interesting and unfortunate scenarios like
Yeah.
we were discussing earlier.
Yes, yes. We were talking about some recent events that were not so pleasant for travelers and all kinds of things in the information system world. Well, final comments from you, basically, the future of Elastic, you're really focused on this end-to-end capacity to bring the power of search to unstructured data, to enterprise data in new meaningful ways. Is that about right?
Absolutely. And we do that for all environments, whether that's on-prem, hybrid, in the cloud. We also have a fully managed serverless option.
Wow.
So any configuration that you might imagine and need those capabilities, we're there.
And hybrid search, we didn't get to that. I'll have to remember that for next time. But folks, look these folks up online. Very, very interesting stuff. Elastic is doing great work. We'll talk to you next time. You've been listening to DM Radio.